Hello everyone, we'll continue with our chapter 8, no? So the last topic that we discussed last time was the 8.10 protoanalysis of alkyl bearings. And so we will proceed with another kind of reaction of alkene, which is the addition of bromine and chlorine. By the way, for those who weren't able to finish and attend the last discussion, you can go to your LMS and then you go for the link to recorded videos. I still have to upload those videos to YouTube. So once I have uploaded to YouTube, I can send you the link. But for the meantime, you can go there and go to the link in the drive, and you can just select on the dates now. The dates that for the lecture that you missed listening. And also I have uploaded two problem sets and another one after our lecture today, so there will be 3 problem sets that you will have to answer before the exam, which will be on katong sa major exam. I think you have the schedule, so if I'm not mistaken, it will be on Monday or Tuesday next week. Okay, so on Friday we'll still have our lecture, no, and we'll utilize our lecture time. And yeah, on Wednesday we can, so that we can maximize the time for the lecture. We can do the lecture on Wednesday instead. Wednesday, and if not, I will continue on Friday. Okay, so we'll use our laboratory time for our lecture. And you're supposed to be doing an online lecture, online face-to-face activity. So I will see what we can do for your laboratory. You can do experiments in the laboratory setting, but I will open that after the midterm exam. So we'll use your laboratory time on Wednesday for the lecture, and then if not, we'll finish Friday. So you have, I think you have 6 hours on Wednesday. We'll finish all those. We only have 9 subchapters left. 9 subchapters left for chapter 8. So on Wednesday, we'll take a break every 1.5 hours and we'll continue our lecture. Okay, so to continue, another kind of reactions of alkenes. So there are too many reactions of alkenes, and at the end of this chapter, you'll have to summarize all of those because there are too many. So summarize those. So another reaction of alkenes is the chlorination reaction, or the addition of your chlorine and bromine, your halogens, your alkene, to form vicinal dihalides. What are vicinal dihalides? Vicinal dihalides are halogens added to your alkene, to both of the alkene, in vicinal manner. Okay, so you have a dihalide that's being produced, like an alkyl halide, but a dialkyl halides here in vicinal. They are added next to each other. So example, if you have your ethene in the presence of your halogen, say alkene, your chlorine, you will have your chlorine here added. So the addition is a useful industrial process because, for example, if we're able to produce your 1,2-dichloroethane in the process of the addition of your chlorine to your alkene, like ethene, what happened is that it can be used to make vinyl chloride during the polymerization process. So abstraction of your HCl, elimination reaction of your HCl to produce our vinyl chloride. So abstract this HCl by an elimination reaction. Remember your E2 elimination reaction, and in the presence of the base, we can eliminate this one, and we actually produce our alkene, or a haloalkene. For example, in this case, you have vinyl chloride. And once you get this one, it's easy for this. Once you have your alkene to do polymerization reactions, in particular, since our starting material for the polymerization is the vinyl chloride, we get our polyvinyl chloride. So that's why here in the process, it is an important, the addition of your chlorine to your alkene is a useful industrial process to get your desired end product. So another example, you have, for example, a translubutene, and what you get here is the presence of chlorine. You get your 1,2-dichlorobutene here. You have your cyclohexene. You also get your, in the presence of bromine, you get your vicinal dihalide. Okay, so it's, you notice the stereochemistry here is like they are on the opposite side. So later we'll look at this. So these two examples show an aspect of these conditions that we shall address later. So we'll look at the mechanism. Why would it be? Why are they not on the same side? Why are they on the untied to each other? Okay. So one of the useful reactions for your halogenation reactions, now the addition of your bromine and chlorine to your alkenes, is that it can also be used to distinguish our alkene. So for example, your bromine is usually colored red-brown in the presence of an organic solvent, usually, let's say, carbon tetrachloride and chloroform, okay? And we do that at room temperature in the dark. So this bromine will actually be added to your alkene. And so in the process, you get your dihalide here. Now what happens, because your bromine reacted to your your alkene here to produce your dihalide, there is actually a rapid discolorization reaction. So if bromine, when you add bromine to bromine alone, the solution in the presence of organic solvent, this is colored red-brown. And when you add this to this one, mawala ang red-brown, no? So it only indicates that this bromine reacts to your alkene to have this. So this is an important test actually that's being used to distinguish whether your unknown compound contains an alkene or not, or your unknown organic compound contains an alkene or not. Of course, this kind of reaction wouldn't happen to your aromatic hydrocarbons, and we'll discuss that in the next chapter. So this behavior also is in contrast to what we observed in our alkanes, or even for our catechol aromatic compounds, your benzene, for instance, they don't react with bromine, and there is no appreciable reaction. For example, if you have your alkane, what we'll get is that from red si bromine, red-brown, what you get at the end of the reaction is that red-brown gihapon. So which means bromine doesn't react to your alkene. Similar way, if you have your benzene here, even if na double bond sa benzene, it doesn't react to your benzene si bromine. And why is that? When we go to aromatic compounds, we'll discuss why would it be so. Okay, so let's look at the possible mechanism for the addition of bromine. So what happens here, we titled this one electrophilic addition. So let's say electrophilic addition of bromine, our electrophile would be the bromine or chlorine. The other term for this kind of reaction actually is also called halogenation reaction. Halogen, just this are your halogen added to your alkene. But the mechanism to this addition reaction of your halogens to your alkene is actually electrophilic addition. So let's go on an electrophilic SIA. Okay, so electrophilic SIA, because in your bromine, you have a, how do you call it? Bromine, you have your nonpolar compound. So once you have your alkene containing an electron pair, when it adds to your bromine, so this bromine atom, once in solution, one of this bromine will acquire the partial negative charge and the other will acquire the partial positive side. That is due to the induced dipole sa bromine na compound, because this is a nonpolar and couldn't determine really which of this bromine because they have the same electronegativity. And like, for example, if you have HBr, now you would know which atom would bear the partial negative charge, and if this, for example, hydrogen, the hydrogen will bear the partial positive charge. But in this case, you don't know. So it's not, there is no permanent dipole. Like one of this would go, one of the electron density would be directed to the bromine, the other would be to the other bromine. So what happens is the bromine, this molecule will utilize an instantaneous dipole. At one instant, the other bromine will bear a partial negative charge and the other will bear a partial positive charge. In that case, when one of the atoms of this halogen will bear the partial positive charge, so here partial positive charge side of the bromine, when this bears the partial negative charge, then this will be added to here, to your double bond. So we will utilize the nucleophile. So our nucleophile here is this one, and this becomes our electrophile. So I'll add here, this is our nucleophile, containing, of course, our electrons from the pi bond, and this is our electrophile. E plus, turn ako sa taas. So which means that there is a positive center in there. Okay, so for the bond that's being formed with bromine, we will be utilizing the electrons from the pi electrons. So one of the carbons will form a bond with bromine. Okay, so when this forms a bond with bromine, this bromine bond will go to the other atom of the bromine. Okay, so most likely it is the bromine or the atom bears the partial negative charge at that instant when this attacks here. So again, because this is a non-polar compound. This is a non-polar compound. No, it doesn't have a permanent dipole. At one instant, one of the atom will bear the partial negative charge. At one instant, one of the other side of this whole molecule will bear the partial positive side. So when that happens, when they are in close contact with this one, so the electrons in the pi bond will attack at that instant the atom that contains the partial positive charge. So that will be our electrophile. And when they forms a bond, then because we utilize the bond to form with bromine, the other carbon atom will then bear the partial positive charge. No, kaya ma-deplete naman siya og bond here. So once you get your carbocation here, then katong kanisiya, the other bromine, since it will take all the electrons with it, it will become negatively charged, and an electron pair here, then it will attack this. This becomes our nucleophile, and again, this becomes our electrophile. This will attack here. Okay, so our arrow, again, if you have to remember, even if you call this one as an electrophilic addition, our arrow will always come from katong na ay electrons, no? Maski pa og gitawag na to siya og electrophilic addition. So electrophilic because our electrophile here is the bromine, okay? And so we get our vicinal dihalide. So all of this mechanism is similar to the ones we have discussed before in the earlier section. The addition of HX, the hydrogen halide to alkene, it does not explain an important fact. So we'll discuss here the mechanism. The addition here is actually an anti-addition. You notice in the previous example here, kanino, they are on opposite side. Okay, so for example, the stereochemistry here is different. So here is directed towards you. Here the chlorine is oriented away from you or from the plane. Here is oriented, so this is the plane of the cyclic compounds. The bromine is oriented up, the bromine is oriented down. So what happened in the addition actually is that there is an anti-addition. The anti-addition of your halogens. Okay, so just remember in that. So another example, if you have your alkene here, which is cyclic, and we have our halogen, your bromine, these electrons from the pi bond will attack the bromine. Once it attacks the bromine, then the electrons here will go to this bromine. So let's get an arrow to this one. What happens is that this will attack this electron, will attack your bromine. Okay, and then once it forms a bond to your bromine, this one is an electrophile. Anong electrophile man na siya? Again, it is a non-polar compound. We use an instantaneous dipole, ha? Yan ako illustrate. So once again, you attack that one, forms a bond, then the bond between bromine will go to the other bromine, and you get your Br. And once you get your Br, first you will get your carbocation here. Okay, once you get your Br, then the other will become positively charged. So kana siya, you will actually have your product Br. I'm not using a pen. Dot, 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 dot. Okay, and a charge here. So you can now attack use the electrons from the bromine to attack the positively charge here. And then once that happens, then you get your product. This is your product. Okay. And what happens is, remember that this is positively charged, so it utilizes an sp2 hybrid orbitals. And to attack this one, since this is negatively charged, no, it will not attack on the same side as this bromine. So that to minimize the repulsions. Okay, so therefore, when this nucleophile will attack this carbocation generated from this step, no, what happens that it will attack at the back. And we will look at the mechanism for that, because you will not get same side of your bromine, but instead we get bromine on the opposite side. It's anti-addition. Okay. So let's go directly to the mechanism of the reaction. So the first step here is that, I think I have already discussed this one. First one is actually you added, what you form here is that a bromonium ion first. Again, one of the atoms of your halogens will bear the partial negative charge and the other will bear the partial positive charge, no, by virtue of the instantaneous dipole that will be created, no, once it will be near this alkene here, it will be induced once it is near the alkene, which is rich in electron density here, electrons here. So what happens if this bears a partial negative charge, the other here will be depleted with electrons, okay, because it is near to this. So once it's near to this one, this electrons again will attack the bromine. Once it forms a bond here, the bond here will be carried to the bromine, the other atom, okay, and it becomes partial positive charge. But there is a mechanism actually once it gets the partial positive charge here, it is what you call as no, even if you get a partial positive charge, this can be easily dispersed, or the positive charge can be easily, how do I term this one, stabilized by the adjacent bromine here, which is electron rich. Okay, so instead of really a positive carbocation, a alkyl halide carbocation, instead of that, what you get is bromonium ion, some bromonium ion, no, or halogenium ion. Okay, halogenium ion, where the adjacent bromine or halogen will form a cyclic ring to that of the adjacent carbon that bears a positive charge. Okay, so that it can be stabilized. And then what you get is a bromide. So next one is you have your step 2. Your one of the carbon atoms, of course, bears a partial positive charge, and there is so much strain here in the 3-membered ring with a very polarizable atom. It will attack the carbon. Once it attacks the carbon, of course, the electrons from this carbon bromine will go to the bromine. You get this one. So when it attacks, it will attack from the back, no, because it will be utilizing an SN2 mechanism to cause the ring to open here. So it doesn't attack from this side where it's close to the bromine, but instead it will attack this side here, and it will be a simultaneous attack, backside attack, to form your halogen here, vicinal alkyl halides, vicinal dihalides. Okay, and what you get in the end, the product is an anti-addition of your bromine to your alkene. Okay, just have to remember this one. Again, so the process shown for the addition of bromine to cyclopentene, what you get is a cyclic bromonium ion. This one is induced. You get an instantaneous dipole. Normally, your bromine, this one has no net dipole, right? But once it gets close to another compound, which is rich in electron density, one of the atoms of this halogen will be induced. So once it gets closer to here, which is rich in electrons here, it will be induced, and this whole molecule of atom will induce its electron density towards your bromine. And this bromine here, the other side, which is far from your alkene, will bear the partial negative charge, and this will bear the partial positive charge. Na magpalayo ang electrons density nila so as to minimize the repulsion. So what happens since one of the atoms now becomes partially positive charge, and that will become our electrophile, this now electrons in the pi band again will add to your bromine, utilizing this pi electrons to form a bond. And what happens actually is you get supposedly a carbocation here. But again, the carbocation can be stabilized by the adjacent bromine atom here in such a way that you don't actually get the carbocation, because it will be stabilized by what we call a cyclic bromonium ion. It will be the bromine atom that will bear the positive charge here. But this one is very unstable. It will soon be attacked, backside attack with the other, with the nucleophile generated from this, which is our bromide. So it will attack this carbon here. Backside attack, no, because it will utilize the SN2 mechanism. So attack at either carbon can attack, because you have your symmetric molecule here, the attack at either carbon of this cyclopentene is equally likely. So regardless if you attack carbon 1 or carbon 2, no, you get the same kind of, you can attack this atom, you can attack this one, but what you get actually is a racemic mixture of the two. You have your trans 1,2 dibromocyclopentane. So if you attack here, the bromine will be here, get your product. If you attack here, bromine will get to this carbon, so you have your bromine here. Okay, so this two actually is, kung tanawin mo siya, no, you have your plane here. Hindi mo na siyang ipa-flip, no, dili mo na siya mag-get inani. Pag mo na siyang i-flip, what happens actually is, dili kani. Now what happens is, kani si bromine is na siya sa taas, kanina po siya sa ubos, kanira gihapon siya. Kani siya imo siyang i-flip, pana, kanira gid siya kanila. So these two actually are non-superimposable to each other, right? But these two are actually enantiomers, right? Remember the enantiomers? So what you get actually are racemic mixtures of the two. They are not the stereomers, they are enantiomers. So attack at is a vertical plane of symmetry passing through, so you get the trans dibromide, therefore it is a racemic mixture. So this one again are racemic mixture of this. You can check on the stereochemistry of this. You have your one, so you have the other atom is hydrogen. So this is chiral, chiral center, chiral center, chiral center. You can check on the stereochemistry of this one. If this is S, this is R. If this is S and this is R, so the enantiomer of this will be R and the S. Okay, so let's see what is this one. You have 1, 2, 3. Okay, so you have, I say 1. So this is your hydrogen here, and you have your bromine. So you get 1, 2. I see 1, 2, 3. So it's an SDIS. And this one you have your 1, 2, 3. This is an R, so SR. This is an S and R. Okay. So the mechanism for the addition of Cl2 and I2, for example, chlorine and iodine also, your other halogens. to alkenes is similar to what you observed with bromine. Okay, so generally what we had described in the mechanism is that we get an halonium ions. Instead of a full carbocation ion, the carbocation ion, when it is adjacent to our halogen, no, it instead forms a halonium ion. But of course, this one is an intermediate and it is also unstable. It can easily be attacked with an nucleophile doing the SN2 reaction to get this one. So as steric-specific reactions, we have observed that the reaction is steric-specific. It is a reaction in which a particular stereoisomer of the starting material yields a specific stereoisomer form of the product. So example is kani. Example is you have your butane, 2-butane. Okay. So depending if we are starting with cis and trans 2-butane, then our product will also be different. So when, for example, when using trans 2-butane and we add bromine, our product is meso. You have your 2,4,3S, sorry, 2R, 2R3S and 2,3-dibromobutane. So it's actually a meso compound. If you get a cis, so unsa man na siya? Kani. No, so if you remember, if you have this one, bromine, if you have a trans na daan and we add our bromine, so our bromine will add like any of this. Let's say this one is where we add the bromine here, and instantly it will form a bromonium ion. Okay, so once it forms that one, actually what we get here is they are trans to each other, but they are already trans here. So what you get is you have a 2R and 3S, and you look at here, there is actually symmetry between the two. No, you can rotate this one around its axis, kani, because carbon 2 and carbon 3, no, you can rotate this around its axis, and you get actually is a meso compound. There is a plane of symmetry, and with this kind of compound, you've learned that in organic in the previous course, no, that a meso compound cannot rotate a plane polarized light, even if this carbon is chiral, because you get a plane of symmetry. Or if we start, for example, with a cis-2-butene and you add our bromine, what we get is, okay, you add here as like anti-addition. So if this is our bromine here, and you get our bromine here, get your bromine here, okay, it's anti. So what happens is that you have your CH3, okay, you have your bromine, you have your CH3 here, you have your bromine. And once you add your bromine, should be anti here, you get here, so it will be added sa likod, no? Once kani pag-form ani niya, and then you have this in ani pang form. Once it add, it will attack the other bromine, will attack sa ilalom from the plane, no? Because your bromine is na diri. Okay, so because of that, you get this one. So you notice this, you have this stereochemistry, HCr and si bromine here. Kani, kita ninyo si CH3 dito na daan. So once if attack sa bottom, katong ikaduha nga bromine, kani, ikaduha nga bromine, once it attack sa ilalom, CH3 is directed dito, sa likod, there is si hydrogen towards sa inyo. And then you have your bromine. And you look at here, the stereochemistry, that's 2R3S. Patuyuko mo na siya, it's actually the same. Here, you get your 2R. Okay, you have your hydrogen directed away from you. You have your bromine. So this is 1, 2, 3. This is R. Your hydrogen is directed away from you. Here's CH3 and kani. So this is 1, 2, 3. It's still R. So 2R, 3R. And what happens actually is because you get a plane here, you know, it can attack, or you can attack either this, or you can attack this one, or then it can attack the other one. You get actually a pair of enantiomers in this way, 2S, 3S. So depending of, so let's look at the mechanism of how it reacts. Okay, so the first one actually, first step for the mechanism of the halogenation reaction, electrophilic addition of your halogens to your alkene, is again the formation of your bromonium ion. Okay, group 7 minus 2, so 5 minus 4 negative. natingala kung anong positive ni siya. So bromine is group 7 minus 2, 5 minus 4 should be negative. So I take note na to ni. It's not negative once it utilizes. Bromine, it's 5 minus 4. Positive. So ano man siya? Ano negative man? It should be, so group bromine is, you have 3, so duha ra gid ka electron. So bromine is group 7 minus number of bonds. So 7 minus 2, 5 minus 4, 5 minus 4. Diba positive? Positive? Ngano negative man eh. Should have been positive di. Okay, so bromonium ion should have been positive because you should have a net charge of positive. So trohon ni siya dapat. So positive diri yan. Sayop lang siya. Okay, we will correct this one. This is not. Oh my God, sorry. What's ito? Ito nga na to positive. It's not negative. Okay, just take note if your bromonium ion is positive now because it will be shared. Supposedly you have a carbocation here.